Hi friends, welcome back to my channel Dr. Mannaganti. In this video, I would like to explain you about significant figures and the rounding of the numbers. Let us have a look at the significant figures first. Mainly there are 6 rules to identify the significant figures in a number or in a calculation. The rule 1 is all non-zero digits and zeros between non-zero digits are significant. That is, if a 0 or a non-zero digit is between two non-zero numbers or two non-zero digits is considered as significant. Look at these examples. 916. Here, number 1 is a non-zero digit. It is between 9 and 6. So, we consider 1 as significant. So, the total significant figures for this 916 meters has 3. Similarly, 45.602. Here 0 is between 6 and 2. 0 is between two non-zero digits, so 0 is considered as significant. So 45.602 grams has 5 significant figures. Similarly, 2022 grams has 4 significant figures. Here 0 is between 2 and 2, so it is considered as significant. Similarly, 2.06 centimeters. Here 0 is between decimal point and 6. So this 2.06 centimeter. It is 0 is between two non-zero digits. So at the point, or we can consider as number. Here 2.06 centimeters has 3 significant figures. The rule 2. Here zeros to the left of the first non-zero digit in a number are not significant. Such zeros indicate the position of the decimal. Let us see here 0.09 meter. In this number 0.0, there are two zeros to the left of non-digit number. So these two zeros are not considered as significant. But the zero after the decimal point is used to explain the position of the decimal point only. There is no significance for the zeros to the left of a non-digit number. So in this 0.09 meter, it has only one significant figure. In the next example, 0.0075 kgs. See here, 7 and 5. These two are non-zero digits. Here, 3 zeros to the left of the non-zero digits. So, all these 3 zeros are not significant. Finally, there are only two significant figures for 0.0075 kg. Rule 3. One of the important one. If a number ends in 0, but these zeros are to the right of a decimal point, then these are significant. Any number of zeros that are right of a decimal point is considered as significant. For example, 8.0 meters. It has two significant figures. The 0 after the decimal point is significant. So, 8.0 meters has two significant figures. Similarly, 7.40. Here the 0 is after a non-zero digit, it is after a decimal point. So we can consider 0 is also as a significant. So 7.40 meters has three significant figures. The third example, 8.500. Any number of zeros that are right of a decimal point is considered as significant. So 8.500 grams has four significant figures. Similarly, 0.0800 This has three significant figures. 0.800 grams has three significant figures because the two zeros to the left of 8 non-zero digit are considered as insignificant or non-significant, and zeros after the non-zero digit are significant. So it has three significant figures. Rule 4. Here, zeros at the end or right of a number are significant, provided they are on the right side of a decimal point. Otherwise, the zeros are not significant. Here, zeros at the end or right of a number are significant, provided they are on the right side of a decimal point. Here, see, 0.200 grams. Here, these two zeros are next to the non-digit number that is preceded by a decimal point. So, in this particular case only, these two digits are considered as significant. Here, 500 grams. Here, there is no decimal point before 5. So, here the significant figure for 500 grams is only 1. These zeros right of a non-digit number are not significant. Similarly, 2000 has only one significant figure. 5550. 5550. It has only two significant figures. Rule 5. Here, the exact numbers have an infinite number of significant figures. See, 5 apples, 3 cows, 4 books, or 50 chairs. These are exact numbers. There is no points in this particular value 5.1, 5.2. There will not be 5.5 apples. There could not be 3.2 cows. There are going to 4.1 book. So we can, these are called exact numbers. These are having infinite number of significant figures because 5 apples can be written as 5.00, 3 cows can be written as 3 equal to 3.000. We can write infinite number of zeros after this decimal point. So we can consider this, it is having infinite number of significant figures. Similarly 50, 50.000 and so on, etc. It is having infinite number of significant figures. The last rule is rule number 6. If a number ends with 0, but these zeros are not to the right of a decimal point, then these zeros may or may not be significant. See here, 5,07,000 grams may have 3, 4, 5, 6 significant figures because this can be expressed in exponential form. See, 5.07 into 10 power 5. 5,07,000 can be expressed in 5.7 into 10 power 5, or it can also be expressed in 5.070 into 10 power 5, or 5.0700 into 10 power 5, or 5.07000 into 10 power 5. Here, the significant figures are 3, it has 4, it has 5, and it has 6 significant figures. In this way, this number, whenever a number can be, there is a possibility to express a number into a exponential form. The numbers in front of that cross mark is considered as significant. So 5.073, 5.0704, 5.07005, 5.07000, it has 6 significant figures. This is all about significant figures. Now we will go to the rounding of numbers. And coming to rounding of the numbers, there are 3 rules as like significant figures. Here are 3 rules. The first one is if you are removing digit that is greater than 5, the preceding number should be raised to one number, increased by one number. 8.638. When we are rounding up the third digit, its preceding number is 3, so one number should be increased to 3, so the value is 8.64. And if the removing digit is less than 5, the preceding number not changed. Here 5.684, if the removing number is 4, it is less than 5, so the preceding number should not be changed, the value is 5.68. And the rule, if it is the removing digit is 5, the rounding off depending upon the preceding number, whether it is even or odd. If it is an even number, the number is as such it will come in the final result. If the number is odd, the preceding number is increased by 1. See here 6.75. Here let us say 5 is, we are rounding off 5 here. So the number 7 is odd number. So we will get 6.8 as our final result. For 8.45, here the preceding number is 4, it is even, so the final result is 8.4. The preceding number is even, the same number comes. If the preceding number is odd, the number is raised by 1. Let us see some examples based on the significant figure and rounding of number rules. Here, how many significant figures are there in a following numbers? Here we have almost 8 examples. In the first example, the given symbol is pi. Pi is having a 3.14159. Like there are infinite digits will come after this decimal point. So we can say this pi has infinite number of significant figures. Let us have a look at product. 23.5, 23 into 5.567. In result, we will get 128.041. Directly, there are 6 significant figures. 128.041 has 6 significant figures. Let us round off the third digit. Third digit is number less than 5. So, the after rounding off, the final result is 128.04. The next one, the sum of 67.9 plus 0.6696. We will get 68.5696. So, the significant figures are 1, 2, 3, 4, 5, 6. There are 6 significant figures. If we look forward about the rounding of the numbers, the number 9, we are rounding of the third digit. The number 9 is greater than 5. So, the preceding number should be increased by 1. So, the result is 68.57. The next example, 0.0054. Here, the zeros right left of the non-digit number are not significant. So here only 5 and 4 are significant. So the number of significant figures are 2. In the next example, 6.023 into 10 power 23. Similarly, 6.625 into 10 power minus 34. This is Avogadro number. This is Planck's constant. All these two given values are having 4 significant figures, 6.023, 4, 6.625. So there are 4 significant figures in these 2 examples. And coming to 2.2000, here the zeros at the right of a non-digit number are not significant. If there is no decimal, all the zeros are non-significant. Here 2000 having only one significant figure, that is number 2. Let us see one example of subtraction. It is 17.8 minus 0.6548. The ultimate result is 17.1452. Here the total number of significant figures are 6. When coming to rounding off, here the third digit is number 5 that we have to go to for rounding off. If there is a 5, the rounding off rule depends upon the previous number, the preceding number. That is number here number 4. Number 4 is even number, so there is no change of the previous number. The final result is 17.14. Here I am showing another example. Express the result of the following data to the appropriate number of significant figures. That means we should write the maximum number of significant figures available for this calculation. 5-point simplification. 5.8 into 0.0784 divided by 8.0. We will get the answer is 0.004456256. Here number of significance we have to find. Here the zeros to the left of a non-digit number are non-significant. So these 3 zeros are non-significant. These 3 zeros are non-significant. The remaining are 4, 4, 5, 6, 2, 5, 6. 1, 2, 3, 4, 5, 6, 7. So here are 7 significant figures for this result. In this example, already they have given some numbers. We have to make it a 4 significant figure numbers. let us have the first one is 4.67538 into 10 power 6. On seeing this number, we can have 1, 2, 3, 4, 5, 6. There are 6 significant figures, but we need to round off for 4 significant figures. That means 1, 2, 3, 4. So after 4, the fifth digit we have to go for rounding off. Here the omitting digit, that is the removing digit, is number 3. It is less than 5. So our rounding off digit will come at up to 5 only. So the answer is 4.675 into 10 power 6. Here the total number of significant figures are 1, 2, 3, 4. 4.676 has 4 significant figures. This decimal we cannot consider as a significant. The next example, 8.98065. Here 1, 2, 3, 4, 5, 6 significant figures here also. So we need to make it as 4 significant figure number. Here, in order to make 4 significant figures, the fifth digit has to be round off. Here the number fifth digit is number 6. It is greater than 5. So the preceding number should be raised by one digit, one number. That is 0 should be 0 should be changed to 1. The result is 8.981. Our result. The next example, 87.9985. Here also 6 significant figures. The rounding of number is number 8. It is greater than 5. So the preceding number should be raised by 1. So 9 plus 1, it is 10. So 1 is 1, the 1 carry forward to 9. It is also 9 plus 1, 10. And then further it is carry forward to 7. It is 88. 88.00. These two zeros we should mention. Otherwise, it is a two significant figure number happens. Here 88.00. Here are 4 significant figures. The zeros after the decimal points are considered as significant. The next one is 0.006754. Here the number of significant figures are 4 itself, because the 3 digits in front of 3 digits on the left of a non-digit number are non-significant. So these 3 zeros are non-significant. So the given number itself having 4 significant figures. When it is let us have a look at how we can make it as an exponential form. See here, 6.754 into 10 power minus 3. There is no ambiguity about the zeros here. So whenever there is ambiguity about the significant figures, we should consider that into a exponential form. Then we can have the clear idea about the number of significant figures. Here 6.754 into 10 power minus 3 have 4 significant figures. The last one is 60000. 60,000. 60,000 has only one significant figure. See, it is having only one significant figure, but we should make it as a 4 significant figure digit. So what we have to do, we should make it into convert into exponential form. See here, 6.000 into 10 power 4. On multiply with 10,000, we will get 60,000. But here the significant figure is 1. But here the significant figures are 4. 6.00. The zeros after the decimal are considered as significant. So 6.000 into 10 power 4 having 4 significant figures. And these are some examples about rounding off and significant figures, rounding off digits and significant figures. I think you have a clear idea about these two topics. If you like my video, please like, share, comment, and subscribe to my channel for new updates and new topics. And thanks for watching my video.